Good day. My name is Frederick, and I'll be your event specialist today. At this time, I'd like to welcome everyone to today's web conference. All lines have been placed on mute to prevent any background noise. Please note that today's web conference is being recorded. We will have a question and answer session at the end of today's presentation. You may submit questions via the Q&A panel located on the right-hand side of your screen at any time during today's presentation. Type your question in the open area and click Send to submit. If you experience any technical difficulties during today's conference, please use the chat box on the right side of your screen to speak with me directly. You may also press *0 on your telephone keypad or use the help menu at the top of the screen to contact an operator privately. Once your issue is resolved, press *2 to be connected back into the call. It is now my pleasure to turn today's program over to Eileen Riley. Ms. Riley, the floor is yours.
Thank you, Frederick. Good afternoon, and thank you all for joining today's live webinar. My name is Aileen Riley, and I'm the Category Specialist for Safety at MSD. Today, we are excited to have Adam St. Clair, an Industrial Imaging Category Manager for Fluke, present about compressed air and acoustic imaging. Adam has served in several different roles, ranging from the factory to the field. He is currently part of the Industrial Imaging Business Unit, working to launch new industrial imaging technology. Adam, we are thrilled you are joining us and look forward to the presentation. The floor is yours.
Great, thanks, Aileen, and yeah, I'm excited as well. Thanks to everybody on the line today. Definitely looking forward to going through acoustic imaging and talking with you all about some of the things that we've learned from our customers since we've had this product out in the market, and definitely encourage you to get your questions answered. I've got several things that I want to go through today that I think are really going to help highlight the technology and some of the ways that it could help in your industries and in your environments. But I also want to leave ample time for questions. So as questions come up for you, put them in the chat box, write them down, whatever you got to do. But I will leave time at the end for your specific questions. So make sure that you're thinking about that along the way. Before we get into it, it is Veterans Day, and I wanted and found it appropriate to just pause for a second and say thank you to anybody on the line that is a veteran or that has a family member or friend that's a veteran. I come from a military family, and so today's a pretty special day for me, a day to remember all of the work done to protect and fight for our country. So thank you, anybody on the line that served. Thank you. Anybody on the line that has family members, make sure you let them know that you're thinking about them today. No, it's a pretty big deal when I call my grandpa and I call my dad and I tell them that I appreciate what they've done. So thank you for everybody on the line. And if you haven't reached out to your veteran friends and family, do so. It's a big deal today. Okay, so here's the topics. This is where I'm going to spend a bulk of my time. Again, this is also open for questions all along the way. So write them down, think about them, keep them in your mind. We're going to start with what acoustic imaging is. So I'm going to introduce you to the technology for those of you that are hearing about acoustic imaging for the first time. This will really get you up to speed on some of the technological development from Fluke. And for those of you that have heard about acoustic imaging, hopefully it's just a quick review on the technology and how it works. I'm also going to spend a little bit of time showing you some of the particulars about the Fluke II-900. So kind of different in a virtual environment as opposed to being in front of you and putting the tool in your hands. But hopefully it just gives you a feel for how the tool works and operates. And then finally, we'll get into the applications. We'll start with diving into the compressed air application or energy savings and one of the primary applications that this tool was created for. We'll dive into that and explore that application pretty deeply. And then we'll spend some time going through some additional application examples and talk about some of the value that acoustic imaging is adding for those applications, which has been kind of unexpected for Fluke, which I'm excited to share some of those learnings that we've gotten from our customers since launching the product. So let's get into it. So acoustic imaging is really what you see on the pictures across the top of this slide. So it's a visual representation of sound. So these images across the top of the screen are actually images captured with an II-900. So you see a visual representation like what we see with our eyes in a field of view. And then you also see that target in the center of the screen that looks kind of like a thermal image. What that is it's a sound map. So This is a target or a visual representation of where a specific sound is coming from based on some of the settings or frequency adjustments made on the acoustic imager. So if you think about it in the simplest form, acoustic imaging is a visual representation of sound or a sound map. I'm gonna just play this video. There won't be any sound, but the idea is really just to kind of show you what the imager looks like and how easy it is to use. So this is one of our application engineers, Justin Sheard. He pulls the II900 out of the box. He sets it into image mode so he can capture images. And then he just walks around this facility and scans for leaks. So it's real-time live mapping of sound. And there you go. This is an example of what you would see on the screen of the camera. You literally just scan areas where there could potentially be some sort of leak, air leak, gas leak, vacuum leak, anything like that. You scan an area and that little target pops up on the screen. And you saw as well just kind of the form factor and the feel of the camera, kind of two-hand operation, big 7-inch LCD screen. So you scan and identify leaks right out of the box. No training needed or special insight in acoustics to be able to use the tool effectively. This is a picture of the main menu of the II900. So I just want to walk you through quickly the different menu options. So again, you get a feel for how the tool operates and works. I'll go left to right here and start with the menu options that show up on the left side of the screen. So the II900 is all touchscreen. There's two soft key buttons on the tool, one to turn it on, the other to capture images and videos, and the rest is all done on the touchscreen. So this is a picture of the screen. The menu options on the left are image. So there's a couple options there. If you selected image, what would pop up is three different options. One, to capture a still image. So you can capture an image of all the leaks that you find for reporting or sharing with your team or creating a work order, anything like that. You can also capture videos. So up to 5-minute chunks of video, you can capture that as well. And that's useful for some environments where there's an acoustic signal that changes. Maybe, there's an actuator that puts something into vacuum or sends compressed air or gas through a system, and it's on more of a pulse or a rhythm as opposed to just a steady state flow. So being able to capture changes over time in video format can be really helpful. The other option in the image, under the image menu, is for what's called leak queue mode. So leak queue mode is capturing images in a mode that's capturing a lot of the acoustic data behind the image. So it's not just simply a JPEG or a screenshot. It's capturing a lot of the sound profile, frequency and decibel range, and the acoustic signal in the field of view. And what it actually does is it quantifies the leak that you're visualizing with the imager. So it'll tell you the severity of the leak, and it'll tell you how much that leak is costing, dependent upon whether it's compressed air or some sort of noble gas. So it quantifies and helps you prioritize the leaks that you find and ultimately want to fix. Then the memory option, that's just where you can go and review the different images or videos that you've captured. So pretty straightforward, just scroll through, select and review or share. The acoustics option, this is where you can fine tune the instrument once you've really gotten a feel for the acoustic profile of the specific leaks that you're looking for. This menu will allow you to dial in the imager to help you visualize those specific types of leaks. Palette will give you the ability to change the color or the way that the acoustics will show up on the screen. So you can change the color palette from a couple of different color options, whatever's easier for you to see. There's also a gray or a grayscale option for folks that are colorblind to be able to see some of the amplitude and where the center of a leak or some acoustic profile is coming from. Marker, that is the marker that you see right in the center reading of the screen here. That's the decibel level. So you can turn that on and off. The decibel level is really helping you understand volume. So how much sound is coming, not just is sound or is it not present in the frequency range that you're looking for sound. And then finally, the settings options. This is pretty straightforward as well. Just changing the date, time, any user profiles or preset configurations that you have on the imager. I do absolutely recommend for all the folks that I do training with or I go out and do on-site inspections, just to get the time and date right and verify that and change it in the settings if necessary. It's nice to have an accurate time and date stamp with all the images in case there's some dynamic changes in the facility or in the environment that you're mapping in. And then the right-hand side of the screen, this is really cool. This is one of the most powerful things about this imager is the frequency range and your ability to select a specific range of frequency that you want to visualize. So you see on the right-hand side, you see the scale there, 5 to 50 kilohertz. That's the range of frequencies that the camera will visualize sounds within. Now we being humans, hear sounds in the lower ends. So, down in like the 2 to 12 or 2 to 15 kilohertz, that's where we can hear sound. But the ultrasounds that we can't hear with our ears can also be visualized by the II-900 up, north of 15, up into that 50 or 52 kilohertz range. And so the yellow box that you see on the screen there, that is adjustable, both how wide that range is and then the center of the range that you're looking at. And why that's powerful is because it helps you in really noisy environments to eliminate all that sound that we hear with our ears and focus in on the sounds of a vacuum leak or the sounds of a compressed air or gas leak and eliminate all of the noise. So that's one of the questions that I get from a lot of customers or folks that are researching the technology is they say, hey, I'm in a really noisy environment. There's motors, there's pumps, there's all kinds of things around me that are creating a bunch of noise. Isn't that going to dilute the camera's ability to visualize some of those really small leaks or those ultrasounds that I could, there's no chance that I could hear? If you have the settings really wide, yes, it won't be able to pinpoint the specific leaks that you're looking for. But if you dial that frequency into the range that will eliminate all of the noise and audible things that we hear and focus up in the ultrasonic range, it does a really good job of eliminating all that background noise. And then finally, you've got that color scale that's representing amplitude. So you see the 52 decibels on the bottom, that's represented by all of the colors showing up in blue. And then as you get warmer or you get up into the yellows, that's representing higher decibel levels in yellow and white. So those are just the different elements on the screen and how you would use the tool out in the field when you're working on visualizing or identifying. Okay, so why acoustic imaging? And this is where we're going to spend most of the time really looking at the applications and the ways that our customers are using the technology to help them solve problems or save money. So energy savings is at the top of the list because this is really the reason that we launched the tool. Our customers were telling us that they wanted better ways of identifying compressed air leaks in compressed air intensive environments because it was really time consuming and inefficient to do. But when they fixed the leaks, when they prioritized that work or hired professionals to do that work, they saw a huge amount of energy savings or reduction in their energy bills by finding and fixing compressed air leaks. So the tool was developed in large part pointed at that application. But what was interesting is we found a lot of our customers found additional ways to add value with acoustic imaging that weren't really on our radar. A lot of our customers are using acoustic imaging to improve or maintain product quality. A lot of people are valuing the tool mostly for the uptime, so they can find leaks faster and get their production lines back up and running quicker, or they can find leaks faster and spend less money on labor for a third party or their internal folks to get back and do the other things that are higher priority or more value add in their facilities. And then finally, safety. A lot of our customers are saying, hey, the ability to find and locate visually the leaks across our facility from 100 feet or more really helps us maintain safety protocols that we have in place and not put people in environments that are going to compromise their safety to go identify areas where there may be leaks. So there's things that we're learning every single day about how acoustic imaging can help our customers, but these would be the top four, and I'll definitely be getting into some of the specific examples of the applications where this has come up. Well, let's start with the compressed air application. So like I mentioned, our customers came to us and said, hey, Fluke engineers, we need a better way to do compressed air leak detection. The traditional methods are not as effective and efficient as they should be or could be. It's costing us a lot of time and a lot of money. It's a high priority thing for us to do, but it's just not easy. So those traditional methods, and maybe you've done some of these things in the past, or maybe you're doing them currently, but we'll start with what's called snake hunting. So a lot of our customers would send a team of people out during planned downtime across a facility that's super noisy, and they would have all of their equipment shut down. And so it would allow them the ability to hear all of those hisses from the air or gas leaks across their facility, but they could only do it when there was that planned downtime or that shutdown time because the environments were just too noisy. But they would send people out, just an educated ear, listening for the leaks, and then marking and tagging them so they could be fixed and restore the efficiency of their compressed air systems. The problem there really was just the fact that you only could do it during downtime in those noisy environments because it was just too loud with all the other noises to do it at any other time. And the other thing that our customers were telling us they did was they used soapy water. So they would take a squirt bottle, they'd fill it up with soap, they'd fill it up with water, and they would go out and they would squirt all of the different, components and fittings and connection points and flanges and gaskets and valves and all of the different areas where there could be leaks. When they needed to find one, they just go spray with soapy water, and they were hunting for any spot that spit bubbles back at them. So this is an effective way to look for leaks. Absolutely. Just spraying and looking for bubbles, like, it makes sense. It's intuitive. You don't need a bunch of training for that. But what they were saying is it just takes way too much time. It's not efficient. It's not a sustainable way for us to go out and find leaks, especially when it's affecting our ability to keep our processes up and running. So just from the efficiency standpoint, soapy water wasn't cutting it. And then finally, ultrasonic leak detectors. This is the pictures that you're seeing on the bottom of the slide here. Somebody using a conventional ultrasonic leak detector, and that is a microphone and some headphones. And you go and you scan all of the areas where there could possibly be leaks, and you're listening for that sound profile that would indicate that there's a compressed air, gas, or vacuum leak. And again, this method is relatively reliable. The problem that our customers said that they were having with this method is that it really is time consuming. So it takes quite a bit of time to go out and find the leaks. You have to change between different sensor heads for the level of sensitivity to hone in on a specific area. And even with a trained professional, at times it can be difficult to really pinpoint it. You can get a general area, but at times can be really difficult to get precise on the location where the leaks are occurring. And so the combination of time intensive and a need for somebody that's really skilled and has quite a bit of training on the technology, those two things were limiting companies' abilities to use the existing methods to go out and solve this problem of finding compressed air leaks. So that's what our customers said. That was the driver behind creating this visual, easy to use acoustic imaging technology. And it was really around trying to help customers go save money on their energy bills by making it much easier to find compressed air leaks at any time in any environment, despite any noise that's happening, and being able to put a tool in the hand of anybody, trained or untrained, to go out and find these areas of opportunities to fix the leaks. Let me share with you just a quick example or a case study of how this technology helped one of our customers, and this was with a local company called Genie, local to Fluke anyway, here in the Seattle area. And as we were prototyping and developing this technology, we took it down to one of their facilities and put it in the hands of their maintenance teams and said, hey, help us understand what kind of ROI we can get by using this technology. if we can help you identify and fix all of the compressed air leaks in your manufacturing process at one of your facilities, what kind of savings is that going to have? So what we did was we took some Fluke power quality meters and we hooked them up to each one of the 4 compressors that they have in their production process at this facility. And so we measured over a 7-day period the kilowatt hours or the energy usage on those 4 compressors just to run their production process. So we were able to quantify and kind of get a baseline for what that system or what those systems were costing in energy usage over a week period. And then we went out and we found all of the air leaks across their production line in their facility that these compressors were feeding. So all of the different pipes and tubes that this compressed air was getting shoved into to support their processes, we identified and fixed as many as we could find. And that took about 3 days of really getting deep into all the different areas of the plant and finding and fixing all of these leaks. And after that 3 days of finding and fixing the leaks, we hooked those power monitors back up to their compressors, and we ran that same load study looking at the kilowatt hour usage over a 7-day period. And what that resulted in is about $50,000 of annualized savings just on their electricity bills. So in just 3 days, being able to reduce their annual electricity bill by almost $50,000. The other unexpected result of it was that we actually were able to increase their efficiency and capacity so much by fixing the air leaks that were present in their system that compressor number 4 completely shut off. There was no need for compressor number 4 to fire up and support the system because we had increased the efficiency so much, which was another huge benefit for Genie in this case, because they were getting to the point where they were looking at speccing in another compressor because they needed some more capacity. So not only did it save them on the energy side, but it also saved them the capital expense of investing in another compressor because we were able to increase and maintain their efficiency at a much higher rate. In addition to that, here's what one of their maintenance managers said, and I won't read the quote verbatim, but they were using traditional ultrasonic leak methods previously, and it just wasn't fast enough and efficient enough to really have somebody dedicated to doing it full time. And so their maintenance manager was saying, hey, it's what used to take us 30 to 45 minutes to go out and find a leak with the traditional methods, the soapy water methods, we're now able to find in just seconds. So in addition to not having to buy a 5th compressor, in addition to saving $50,000 on their energy bill every year by finding and fixing the air leaks, they're also able to help reduce the amount of time that their team was spending to find those leaks from 30 to 45 minutes per leak down to just a couple of seconds to go identify where fixes needed to happen. This was really the unexpected part of this product launch for us. Like I said, it was all about energy savings, and that's what we thought our customers wanted. That's what they told us they wanted. And we were able to deliver on that. But it was interesting to us all of the different ways that, like I said earlier, all of the different ways that our customers were using acoustic imaging technology to help that we didn't even have on our radar. So here's a couple of quotes that I love from customers that I've talked to that are using the technology across their facilities. This top one, the Fluke i900 is a primary part of our quality control program. It was really cool to see how people are just using this technology to help them in ways that we would have never imagined. And I've got some examples that I'll show you in just a minute of where this quality control piece comes into play, but pretty cool. It has nothing to do with energy savings. We can identify the source of our problem 10 times faster. I just went through that example with Genie that I think speaks pretty well to that. So just the labor efficiency piece is having a huge impact with our customers. And then finally, I bought the i900 because it's my job to keep people safe. I've got some examples of where safety really comes into play, not an intended way that this tool or this technology was going to add value, but something that our customers came back to us and said, that's why I love this tool. Nothing to do with energy savings. So Now I'll get into some of those application examples and show you some of the particulars around those insights that we've gotten in the last year since we've had the tool out on the market. You look at the top industries served. I put this up here just in case you fall into one of these categories or you're in an environment that's similar. I just wanted to highlight some of the places where we're finding a lot of success and value added from this technology by industry. So automotive, all manufacturing facilities are, at least larger scale manufacturing facilities, are pretty compressed air intensive. So we're seeing a lot of application and use cases there. Food and beverage, which is similar kind of process manufacturing, but again, just really compressed air and gas intensive to facilitate the production process there. Hospitals are actually finding a lot of pretty unique use cases for acoustic imaging, not just in the facilities maintenance world, but also in some of the patient care applications that, again, weren't on our radar. Transportation and logistics centers, also ones that are finding a lot of value by having acoustic imaging technology in their facilities. And these are going to be kind of the bulk of application examples that I'll walk you through. This list of industry serves by no means is meant to be exhaustive. I'm not trying to communicate that if you don't fit into one of these buckets, that there's no use for the tool. This is just where we found the most success and impact in the short term. But I would encourage you to just think as we go through these application examples of things that are maybe exactly the same as the environments that you're in or similar. So these applications examples are really about getting your wheels turning. I want you to be able to understand the tool, not just theoretically, and go through the case studies that are pretty abstract. I want you to see the particulars. So that's the goal here. And again, questions often come up during the application example. So be thinking of it, get your pen ready, or type them into the chat as we go. All right, this first example is a process control or a process valve control panel. So this customer was coming to us and saying, hey, we have this issue on this valve control panel. We keep getting the electrical system keeps shorting out, and we can't figure out why. It's an electric and pneumatic control system, and they thought it was just wired wrong, or it was some sort of electrical root cause that was causing the system to short out. So out of curiosity, we took an acoustic imager over to this control panel, and we just did a quick sound map to see if there was anything that could be highlighted from an acoustic standpoint on this control panel. And what we found was that one of the compressed air dryers wasn't operating efficiently to pull all the condensation out of this control panel. And what it was resulting in was a bunch of condensation buildup and moisture buildup in this control panel. And when that moisture reached a certain level, it was causing the electrical components to short out. So a neat example here, because it was an application where, we thought the root cause was electrical, turned out it was mechanical, and the II900 helped us to quickly get to root cause, and it was completely different than any of the folks on this team thought it was. This is an example of a pressure regulator that's got some significant corrosion. This particular pressure regulator had been changed out 3 times in the same year. And again, the root cause was unknown. So the customer was telling us, hey, can you help us understand or get to root cause? We've got this pressure regulator that keeps corroding and shutting down the production facility or this part of the production process. And we can't figure out why. It was just one of those unsolved mysteries at this facility. And so again, out of curiosity, we took the acoustic imaging technology out there, did a scan and got a sound map. And what we found was that there was a CO2 leak right next to this pressure regulator, and that off-gassing of the CO2 was creating and causing that corrosion. So the root cause was not a faulty pressure regulator or anything wrong with the install or anything like that. It was that CO2 leak right next to that regulator that was continuing to cause them to fail. and changing out the regulators wasn't going to do anything. Everyone they put in there was going to continue to fail until they fixed that root cause of tightening up that CO2 leak. So again, just a neat example of getting to root cause and having it be something that was really off the radar of anybody that was trying to work the problem. This is an example of an air handler ducting system. This is actually a paint booth inside that big silo that you see on the left, kind of where the stairs are going up. And then that big pipe coming out the side, that's sucking. It's got a damper inside there. It's sucking all of the air and the particulate out of this paint station. And this particular part of the ducting system had just recently gotten inspected and retrofitted by a third-party company that came out and did it for this particular group. And they said, hey, everything's working properly, everything's good to go. But they were having issues with the damper inside of this ducting system. And they really couldn't figure out why. They were telling us, hey, we just had a third party come out and inspect and certify this, but our damper is sticking, and we're really confused, trying to figure out why that's happening. So again, took the acoustic imager over there, did a sound map, and found that there were several locations on this coupling, or where these two pipes were coming together, that there was pretty significant gaps in the seal where there was fasteners. And so there was this particulate and air particulate from the air that was getting sucked into this ducting and causing a bunch of buildup on the sides of the ductwork that was impacting the damper's ability to do what it needed to do and efficiently suck the air out of the paint room. And so we were able to identify those specific gaskets and areas where there was significant leaks causing the infiltration and buildup for the ducting system that was impacting the damper's ability to do what it needed to do. This is an example of how the acoustic imager is helping one of our customers maintain product quality. So what you're looking at here is a bunch of air lines that are under the cab of a semi truck. And these lines, they control a bunch of different functions on the truck itself. And this is actually an example of a truck that is just coming through the production line. So one of the quality control checks that this company goes through on every one of the trucks that comes through their line is they use, or at least they used to use, a traditional ultrasonic leak detector to go through and scan each one of these fittings. And they would look for leaks. The last thing that they wanted was a customer to receive a truck that stopped functioning properly right after they got it or before they got it. And so they would scan every one of the fittings and connection points for leaks. This truck in particular had just passed the quality control inspection by the team. And we were out with an acoustic imager, and they said, hey, maybe this would help us be faster at doing our quality control checks on all the trucks that are coming off the line. And so I said, yeah, do you have a truck that we can scan and see if we can find any leaks? And they said, well, the one that we have just came off and passed, so I don't think we'll find any leaks on that particular truck. So I said, well, let's give it a shot, and we can at least see if there's something that you missed. And so we took the imager over there. Obviously, we found one. And they adopted the technology right away for a couple of reasons. One, it was just faster. Now you don't have to scan every single connection point. You just have to put the camera in the field of view where all of these connection points are, and you can visualize anything in the field of view. That's one. The other was just to reduce some of that human error in the process. So these are trained professionals that do the job all the time to go and find and listen for these leaks. But there's times when you miss things, and that's normal. And so this company was invested heavily in making sure that they fail-proof the process as much as possible. And acoustic imaging was one of those ways that they were able to help improve the process. This is an example of a dust collection system. So again, a pretty abstract application, if you will. We were just really curious. We were walking in between two different parts of the plant where we were looking for compressed air and compressed gas leaks. And one of the guys that was wanting to see the tool, he was just super curious and like scanning around and looking at different places just because he thought the technology was cool. And he pointed it up at this dust collection system, and he saw this target. You know, he saw the acoustic map pop up, and he says, "Hey, Adam, what do you think this is?" And I have no idea. I mean, I don't work on dust collection systems often, so you know, I threw a couple hypotheses out there about what it could be, asked a few questions, but ultimately we didn't figure out what it was while I was on site. But we took the picture, we sent it to them, and they went out and investigated a little bit further. And they got a team member up there on some scaffolding and up in a scissor lift, and they actually found that there was some loose components on their dust collection system that were rattling around and about to actually come loose, which would have really impacted the dust collection system's ability to perform. So just a neat example. It has nothing to do with energy savings, has really nothing to do with cost savings. Unless you think about the potential for what would happen if that dust collection system shut down because you know, some of the critical components rattled off or shook free. So they were pretty impressed with just the fact that, you know, acoustic imaging is not about air or gas or vacuum specifically. It visualizes sound. So anytime sound can help you solve a problem or identify a problem, acoustic imaging could really be a benefit. This is an example of some ductwork at a nuclear power plant facility. So they've got this huge ducting system that's sucking all of the off-gassing from their production process out of their facility because it's environmental hazard for all of the employees that are inside working to be breathing in any of that particulate or any of that off-gassing. So they have these huge systems that suck the air out, and this is one of the ducts that pulls the air out of the facility. And the environmental health and safety team member was interested in looking at some of the ducting to see if it was able to pick up on any potential leaks in the system that could impact employee safety or impact the system's ability to maintain employee safety. So we scanned a few different places. This is one of a few different examples along the ducting system where we found that the system was compromised, but pretty easily around you know, these different connection points where you've got the different fasteners and couplings here. We are able to find and fix all of the different areas along this ducting system that could have potentially impacted employee safety by not having good tight seals on their collection system. This is an example of a logistics center where they've got miles and miles of conveyors or overhead roller bearings. What the process was at this company to help prevent any kind of shutdown because their conveyor systems weren't working properly, or because they would get, you know, bearings that got gummed up and stopped working, and they would have to send somebody up to fix. They were on a pretty robust preventive maintenance schedule. So they would send employees up to do routine maintenance and you know, grease bearings or replace bearings to make sure that their conveyor systems weren't going to fail unexpectedly. And they spent a lot of money not just on the labor to do all of that preventive maintenance, but also on the scaffolding that it would take to get people up overhead to be able to access these different bearings. And in fact, they were spending almost $5 million a year just on the scaffolding to do this preventive maintenance. What they were able to do with acoustic imaging, given the fact that you can visualize you know, any sound anomaly from a considerable distance away, they actually switched from a preventive maintenance model to a predictive maintenance model. And so rather than just sending somebody up on this expensive scaffolding to go do maintenance that really didn't need to be done just to prevent a failure, now they're sending people around on a schedule to just scan these high risk or vulnerable areas. And when they see the acoustic anomaly, then they're spending the time and money to get people up in the air, fixing and doing maintenance on the bearings only when they need it, not just because the calendar or the work order system tells you to go spend the time, money, and effort to go grease or change out a bearing. They do it when it needs to happen. So a considerable amount of savings in that application for this customer. This is an example of a control air regulator, and I love this one because we were walking through this facility and I heard this hissing. I heard this control air regulator just spitting out air, and I said, "Oh, hey, I think there's probably something going on over here. Let's check it out." And the team that I was with was saying, "No, Adam, this is a control air regulator. That's supposed to be letting off air, pressure relief part of the system." And so I scanned it and I took a quick picture and I said, "Hey, it looks like there actually might be 2 leaks. Do you mind if we take a little bit closer look?" And they were kind of confused, but said okay. And so we went and we took a more defined image at a higher frequency range, and where you see that big red circle, that's the higher amplitude, and that's where the pressure release system is actually letting off air from the system, which is absolutely supposed to be happening. But then there's also that smaller circle that you see kind of up and to the right of that main target there, and that was a gasket between the 2 mounting surfaces that had failed. And so they were able to improve the efficiency of this control air regulator and really kind of find in a situation where you think that an air leak should be happening or you should be hearing that hissing. They were able to find an actual faulty part of their production process or the components to facilitate it. So it was a neat discovery, and they were pretty impressed with that. This is an example of a noble gas or an argon line. So I'm sure you all have seen these huge storage tanks outside of a facility where there's helium, nitrogen, argon, different noble gases that are stored and piped into a facility to support a production process or some sort of process within a facility. And these gases are extremely expensive, direct cost gases. And when they're leaking, I mean, that's literally just money that's flowing right out of your pipes or right out of the system. And so this company used a whole lot of argon, and it was one of the biggest cost pieces of their production process in their facility. And so when we were able to go out and identify the different argon leaks and fix all of those, it increased their profitability for their output or what they were manufacturing considerably, just because of these. This is 2 examples of the 10 different argon leaks we found from storage tank to where it goes into their production process. So that was direct cost savings, not energy savings, but still a pretty significant result for them in improving their bottom line. And this is, again, just an example that it's not just compressed air. It's a sound map, regardless of what's causing that sound. This is an example of robotics. So this is a pick and place machine. It reaches down, it picks up components and moves them and sets them down somewhere else. This particular pick and place machine had just gotten retrofitted, and they have little vacuum suction cups on each of the 4 corners that pick things up and move them and set them down. And when they go bad, or when the pick and place machine at this facility starts malfunctioning or not working properly, they do a complete tear down and retrofit to make sure that this pick and place machine doesn't fail again for a long time, because it's a pretty significant cost for downtime in this particular process. And so they were telling us that, hey, every time it fails, we completely do a full retrofit, and regardless of if it's just one of the different vacuum systems that's failing. And all of the time to fix it, as well as the components to fix it, were pretty expensive. So what they're doing now is they're able to see exactly which part of the system is failing or not failing. In this case, where you see the acoustic map, that's where it's functioning properly. Where you don't see the acoustic map, that's where it's failing. And so in this case, they were able to, instead of changing out all 4, they were able to change out just the 3 and save the time on fixing it from a labor standpoint, and also save the money on components for this particular pick and place. All right, here's the last one, and then we'll get into your questions. This is just a neat example of a steam leak from a pretty considerable distance or hard to get to place. So there's a lot of different technology, thermal imaging, just to name one, that can help identify steam leaks or faulty steam traps. But this technology is helpful, especially in those situations where it's just difficult to get to or get a good clean thermal image of the steam trap or the steam system. So I put this example in here just because steam is so expensive that it's often a really good thing to check if you have acoustic imaging technology in your facility. So even if it's not the main application or the primary application, it's definitely one that can have a pretty significant impact on cost savings. So keep that in mind as you get the technology and you're starting to use it for a bunch of other things. Don't forget about those steam traps. It can definitely save you some bucks. That was a lot. We talked about the technology. We talked about the applications. Hopefully it was helpful, but I'm sure there's some specific questions. So let's use the remaining time to get those questions that you have answered specifically.
Adam, this has been fantastic. I just wanted to jump in and say that MSC and Fluke would like to offer today's webinar attendees a special discount on the purchase of the Fluke II900. So with this discount, you can receive up to 30% off MSC's list price when you order using a promo code GW98490873. So this is only for the attendees on this webinar. So I just wanted to let everyone know about that, and you will also receive a follow-up email with the promotional code, and that all purchases must be made between 11/16 and 12/31. So I wanted to let everyone on the call know before we jumped into some questions. So really great offer there. Adam went through how awesome this product is, so we wanted to offer that to everyone here. So let's kick off the questions. If anyone has any questions, please post them in the Q&A chat. We actually had a couple sent in privately through the webinar. So the first question here for you, Adam, is on one of your slides, you showed that the II900 can be used in hospitals. Can you give an example on some of the more common applications for hospitals?
Yeah, absolutely. Thanks for that question. So in the healthcare or medical facilities that I've gone to that are using this technology, they're using it primarily for medical air and gases. So they're usually kind of down in the basement of the facilities maintenance area. You've got these medical gas and medical air tanks that are supplying medical gas and air to all of the different patient rooms. And so they're inspecting all of those storage tanks and fittings along the route or the line from storage tank to patient room, and finding and fixing all of those leaks. So being able to kind of improve customer care and maximize the efficiency of the medical air and gas systems in their facility has been pretty impactful. We've actually had a couple of the medical facilities since they've had an increased patient load from COVID, and a lot of them, needing to receive medical air, have found a lot of use for this technology just to make sure that they're maximizing the efficiency and capacity of their medical air and medical gases. And we've also seen quite a few examples of the acoustic imaging technology being used to make sure that ventilators are functioning properly. So some of the different vacuum areas or where the air is coming out of the ventilators as well. We've seen the technology used there just to make sure that all of the medical equipment is functioning properly.
Awesome. That was perfect. It actually answered the second part of that question, which was related to COVID. So it looks like we have a couple questions that were put in the chat. So the first one's from Ken. Are there presets for types of leaks? And what is the lowest pressure that a leak gives an acoustic signature?
Did you say presets for types of leaks?
Yes.
Yeah, Ken, great question. Presets is not something that we have on the Imager right now, but it's something that our technology development team is working on. It makes a ton of sense because there are different acoustic profiles for the different types of leaks. Um, it's relatively easy to find where, like, what frequency band you should be looking for a leak within, though, because there is a scale, and I could go back, but I don't want to fumble through trying to get back to the specific slide. But there's a graph on the screen at all times that shows the different amplitudes for the decibel levels across the frequency range. So that allows you to kind of visualize which frequency range you should move the imager into in order to pinpoint that specific sound or that specific type of leak. So let me answer your question directly. No, we don't have presets. It is something that we're working on, but the tool is pretty intuitive and allows you to pinpoint the different sound signatures right on the screen without having to do any much adjustments to the acoustic settings. The other part of your question was, what's the lowest pressure you can visualize leaks within? Its pressure is one of three primary variables that impact the imager's ability to visualize sound. So you've got pressure, you have density of gas or air, and then you have the flow rate. So you have, it's impossible without the other variables to say what the lowest pressure is. I have visualized leaks as low as about a half PSI that were pretty sizable leaks with relatively good flow. So you can get down into some pretty low pressures. Obviously, the higher pressures are going to be easier to visualize, but if the other variables are in your favor, low pressures are also something that we can visualize. I would encourage you, Ken, as well, if there's a specific application that you've got in mind. We've got several field engineers out there. If you need to prove your application, I would encourage you to reach out to MSC as well to help facilitate an on-site demo to see if your application is one that we can visualize with the acoustic imager.
That was great. Thank you, Adam. It looks like we have a question from Jason pertaining to the cost. So we will follow up with you after the webinar separately about that. And I see you asked if it could be loaned out. And then we have one last question from David, and then we'll announce the giveaway winner. So the last question we have for you, Adam, is how is the II900 calibrated?
The tool actually doesn't need to be calibrated. It's not like most of our other test and measurement equipment that needs to be dialed in. I mean, we send it through a performance test on our production line to make sure that the imager is able to visualize sound between 2 and 52 kilohertz, and that the decibel readings are accurate to what we're putting in front of the imager. So it's not calibrated in the sense that it's tweaked and adjusted to reach a certain level of performance. It's run through a performance check to make sure that it's visualizing the sound in the defined frequency ranges and providing an accurate decibel reading output. I hope that gets at the heart of your question. It does not need to be sent in annually or biannually for calibration or anything like that. It's just a performance check that we do, and we've got no reason to believe that it wouldn't be functioning properly. If it wasn't functioning properly and needed to be adjusted, it would just be like a service return, and we wouldn't calibrate it. We would just replace a sensor head or something like that. It's kind of a pass fail.
Great. Awesome. Thank you for that. So now, without further ado, we'll announce the giveaway winner. So drum roll. Our winner is Cody James. Woo! Congrats, Cody, we will follow up with you on the best way to send you this awesome giveaway from Fluke. So if anyone has more questions, feel free to ask in forums at Better MRO. Thank you again for participating today, everyone, and a big, big thank you to Adam. This has been fantastic. So much information here. So please be sure to check mscdirect.com/BetterMRO for the latest trends in the safety industry.
All right, thank you all.